All right, today we're talking about dictionaries. Not a dictionary as in a book you take off your shelf and it's got, definitions of words or whatever, but the idea of that is why it got its name. A dictionary is a connection between one data item called a key and another data item called a value. And other languages call them maps. Why open that? So dictionaries link up keys to values. So for example, you could have a Spanish to English dictionary. And if you looked up that, you get that. If you looked up that, you get that. If you looked up that, you get that. Just like that. So these would be the keys that you could use, and these would be the values. Or if you're going to make a English to Spanish dictionary, the roles would be reversed, right? You could say, that would be the key, and that would be the value. And that would be the key, and that would be, whoops. Like that. So it's a connection between keys and values, or one value and another is another way to think of it. Right. So they show an interesting way of declaring a dictionary here. Let me see if I can pull it up, which I hadn't really thought about before. I'm looking at the Python for Everybody definition here, which is to declare a dictionary like this, where you're listing the keys followed by their values. So if I was going to just play around with something like that, I might come up with prices. Here's my goal. I want to be able to do something like print the price of eggs and get a value. And then later on, I want to be able to print the price of milk and get a different value. It looks like a list, but we're not putting an index number in there. We're putting the so-called key. And the key is the value. The key is the way that Python looks up in a list to find its result. This might be worth us all doing. I'm going to go ahead and launch idle so that I can type it up. Feel free to play along. Apparently we're on S. So here's what I'm going to do. I'm going to say price is equal to, and I'm not using square braces. I'm using a dictionary. Dictionaries are defined with the curly braces. Slightly different. I'm not going to say that's the only time you use them, but in general, very good question. These will mean lists. These will mean tuples. And those are just regular parentheses, and these are curly braces. Those will mean dictionaries. Okay, so I'm going to say that the price of eggs is $1.99, whatever. So if I want to print the price of eggs out, print price, quote, eggs, like that, it should print $1.99. And it did. Now what if I misspell eggs here? Like what if I take the E out? It's going to blow up. Right, because there's no such key in there. Just like if you pass a bad number in as the index value for a list. right? If you put something past the end of the list, you know, if the list has a length of 10 and you specify an 11 as your index value, as your subscript, it's not going to work. Okay, so I'm going to add a few more items to my list. I'm going to just put a comma here, and I'm going to say that milk, end quote, colon, costs $3.99, comma, bread, end, quote, bread, end quote, comma, and bread's not too expensive. Let's say that it's $2.50 a loaf. $2.51, just so that everything has 3 digits, whatever. Okay, so hopefully you can see what's going on here. I think it'll work if I tab it out like this. I think the code will still run if I have it spaced out like that. Nope, nope, nope. Oh, I made a mistake there. That should be a colon. All right. So when I printed out the price of eggs, it said $1.99. If I change this to milk, it's going to say $3.99. If I change it to bread, it's going to say $2.51. What if I want to print them all out? For key in price, print the key, comma, and then the price based on that key. So that should print out eggs and the price of eggs. It should print out milk and the price of milk, and it should print out bread and the price of bread. And there we go. Got our little shopping list here. What if the price of milk changes? Cows become rare, the price of milk skyrockets. Price, subscript, quote, milk, end quote, end brace equals, you know, now it's $5.99. It's gone up by $2. I'm just going to copy and paste these print statements here. Right there. Yeah. All right, and so you see, that did not put a second entry into the dictionary. It just replaced the one that said $3.99 with another that said $5.99. Just like crossing off an entry in the dictionary and writing in your own definition, right? We replaced $3.99 as the value that is associated with the key milk with $5.99. It didn't add a new entry to the dictionary, but we can add new entries to the dictionary if we want. Let's say that while we were adding milk, we were going to add something else. The price of carrots, end quote, in square braces, equal to 1.23. And there we go. There's our 4 pieces of data that are in our dictionary right now. So this established a new relationship, carrots being the key and 1.23 being the value. Other languages, some other languages call that a map. That's a mapping between this key and this value. And I already showed one example of using a dictionary to contain a set of information about a specific entity, which we were doing as different attributes of the same entity. And what do I mean by that? What if we did this? That makes an empty dictionary. That those are curly braces. And then we said, why did I say main? Male, right? And then male subscript 2, you know, is equal to, you know, joe@google.com. Male subscript from, end quote, end subscript is equal to, you know, john@rose.edu. and male subject, end quote, end subscript is equal to free tickets to the play. All right. So this dictionary is not so much a collection of different pieces of data. You know, here we have milk, and here we have carrots, and here we have this, and here we have that. Instead, it's kind of one piece of data that has different attributes tied to it. But effectively, it's the same thing, right? It's just a mapping of keywords and values. Just that this is for a collection, you know, of groceries or whatever, and these are all headers for an email package, for an email. And we could do the same thing. We could use a for loop to print that one out as well. For key in mail, colon, print the key, comma, and then the mail subscript key in subscript, like that. Then if we wanted to change the subject, we could do that. We just do mail subscript subject equals, and we could change it. We could make a whole set of dictionaries where each dictionary was a separate email message, and we could add them all to a list if we wanted to. Right? We could call that mail 1 and change all those to mail 1s. And then we could do mail 2 and create a different dictionary that was a set of information about a second email message, and mail 3 and so on. And we could add them all to a list. All right, I'm going to go and see if I like the way that this alternate online text that I sometimes use. I'll put a link to it in contents. So if you go to contents, textbook, you'll now see one more textbook listed in the online one, How to Think Like a Computer Scientist. So I went to this chapter 20 based on dictionaries. So they're a mapping type. They map keys to values. You just create an empty dictionary like that. Or you use the DICT keyword. If you want to make an empty dictionary, you could do it like this. D is equal to that. Or you can say D is equal to DICT question mark, excuse me, parentheses and parentheses. There's no difference between those two things. This is easier to type. So I would lean towards that. So dictionary operations. You could just print and then put the dictionary variable right there in it. Right, just like you can print a list out like that. But if I say print it with a loop, I want you to use a for key loop, like I was doing here in our code. Right, that's printing it with a loop. So if I ask you to print a dictionary, don't just do print parentheses mail or print parentheses price. And we could do that. Let's see what the output looks like. Right. This last thing I'm going to do here is going to be print parentheses mail. We'll see what our dictionary looks like, and we'll see that it has data in it, but it's not printed with a loop. And that's what the data looks like. You see, it's showing just a connection. The to key has that value. The from key has that value. And the subject key has this value. Now, these don't have to be all of the same type. Right now we have strings and strings, right? But our key could be a number. And the values could be strings. Or the key could be a string and the value could be a number. That was the case here. So one use for dictionaries is to create what's known as a frequency table. Like if you have the word Here, let's do this. I'm just going to say S, and I'm going to type in a sentence. Or maybe it's not going to even be a sentence. It's just going to be a string of characters, right? This has got a lot more A's than anything else. And it's got a few B's, and it's got a couple of C's, and it's got like 2 S's. We might be curious as to how many A's there are, how many B's there are, how many C's, and how many S's there are in it. And if you have a finite list, like if we know that we're doing only uppercase letters, if we know that we're doing only lowercase letters, we could do something like this. The A count is equal to S dot count, parentheses, quote, A, end, like that. And the B count is equal to S dot count, the number of B's. And the C count is equal to S dot count, the number of C's. And the D count and the E count, well, you know, if you don't know in advance what characters you're going to be using, then this is a really bad idea, right? You know, what if there were characters with accents, you know? We were going to do the N with the little, you know, the diacritical mark above it, since we've been talking about Spanish a lot, you know, the N with a squiggle or the O with the umlauts and all the other diacriticals, right? We'd have to put, you know, 70,000 different one of these in order to get it to support all the different, you know, Romance languages and, you know, Korean and this and that and the other. So this is not a great way to do it. This works if you know in advance what the range is going to be, right? I've almost got it right. You know, I just could throw an S and then I could be done. But instead, what I want to do is I want to process this from beginning to end. And every time I find an A, I want to update a dictionary, increasing the counter for that. So we're going to create a dictionary that's going to have a mappings between the letter and the number of occurrences. So when it prints, it ought to print something like this. A occurred 23 times. B occurred, you know, 10 times. C occurred, you know, 5 times. And S occurred twice, or whatever, right? So these are going to be the keys right there, and these are going to be the values. It's not going to even be in the dictionary until we add it the first time. So if we printed the dictionary out before we started going, it wouldn't show anything, right? We could just use another for loop, but it wouldn't show anything. So what we're going to do is, the first thing we're going to do is we're going to declare an empty dictionary. And then we're going to loop through this string letter by letter. And if that value is already in the dictionary, we're going to increase its counter by 1. And if it's not in the dictionary, we're going to add it. So let's make our... I'm just going to comment this stuff out because, this, like I said, this is a bad way to do it if you don't know, unless you know in advance which letters comprise our string or which values can be in the list. So that's not a great way to do it unless you know in advance which elements make up the list or the string. So I'm going to make this dictionary called L count, short for letter count. That's an L, not a 1. I'm going to make an empty dictionary, and then I'm going to use a for loop, and every time I hit a letter in it, every time we get a new letter out of the string, we're going to use that letter as the key. So for letter in string, for letter in S colon, now I'm going to do this kind of the wrong way. L count, subscript, letter equals 1. And then I'm going to print it out. And this is not actually correct. We're going to go back and we're going to modify that because this is going to set them all equal to 1. It's going to show that we had 1A, 1B, 1C, and 1S, and that's it. So again, for key in L count, this for loop is going to look pretty similar over and over and over. Print the key and then L count subscript key. Oops, I've got a mistake. And I just closed my code. Yeah, I had some stuff here. All right, it shows we have an A, B, a C, an S, and a D. Oh, and I didn't even know that there was an F in there. But it doesn't have the right counts. What we need to do is not just say, oh, that's a 1. We need to check to see if it's already in the dictionary. And if it is, we need to increase it by 1. Checking to see if something is in a dictionary is done the same way that you check to see if something is in a string or a list. You use the word in. So, if letter in L count, now I don't know what to do yet, so I'm just going to put print, quote, letter, comma, already in dictionary. And I'm going to replace that with better code when I figure out what it is. And then backspace, else, colon, like that. All right, and so it was running through the string, you know, and the first time it found an A, it added it to it, and the second time it said, oh, well, it's already in the dictionary. And that one's already in the dictionary, and that one's already in the dictionary, and that one's already in the dictionary, and so on. So it did create a dictionary, but the dictionary is still all just letters and the count of 1. So I think what I might do is I think I might say count is equal to 0, meaning that unless we know it's in the dictionary, we're going to assume that its count is 0, right? It's an empty dictionary. There's not going to be any A's. There's not going to be any B's or whatever. But if that letter is in the dictionary, we're going to pull that count out. I'm going to delete that print statement. Count equals L count subscript column subscript letter, like that. And I'm going to get rid of that else completely. So we'll have the count at that point. We're assuming that there's nothing in that dictionary for that letter. But if there happens to be one, great. As soon as we get that out, we're going to need to add 1 to it, regardless of whether there weren't any in there before or there was a certain value. So let's just do count plus equals 1 as our next statement. And then we're going to add this back into the dictionary. We're going to do a new set into our mapping, into our dictionary. L count subscript letter in subscript equals count. I'm going to put a couple spaces here to try to make it a little bit easier to read. And that will be our final solution. Unless I made a horrible mistake that I'm not planning on making. I'm expecting this time to work. All right, and so it found 23 A's, 7 B's, 3 C's, 2 S's, 2 D's, and 1 F. I hope this makes sense. This part here checks to see if that value is in the dictionary. If it is, we get its value, right? Because it's a key value thing. And then we add 1 to that value. And then we set that. I kind of want to make one more change, and I'm not sure if it's going to make it harder or easier to understand. But I'm going to delete that line that says count is equal to 0 there. And I'm going to do else colon count equals 0 here. So here's that little block of code now. I think I'm going to add a comment above that saying that what we're doing, get the count for this letter. And then I'm going to add another comment here add 1 to the count, and set into the dictionary. All right, that worked. Same idea, right? The other solution just had this up at the top, and here I broke it out as an if-else, hoping to try to make it make sense that if it is in our dictionary, we retrieve the value from the dictionary. Otherwise, we set the value equal to 0, then we add 1 to that value, and then we set it back into the dictionary. And the whole time we're using what I called letter as our key. Now this code would work just as well if S was not a string, but if it was a list. I'm going to kind of prove that to myself. And then I better stop and to make sure that everybody else is got it going. I'm going to redo what S is. It's just going to be a list of things. And we know that we define lists like that. And just put some colors in here or something between quotes, like red, end quote, comma, blue, end quote, comma, red, end quote, comma, orange, end quote, black, end quote, red. Okay, so we should see that it's going to have 3 reds, 1 blue, 1 orange, and 1 black when it's done. And this is one of the cool things about Python, is that since lists and strings are so similar, the exact same code is going to work, regardless of whether S was a string like that, or whether it's a list as it is now. Same idea. Red appeared 3 times, blue was in there once, orange was in there once, and black was in there once. Whichever. I'm going to cut that and paste it and put it under here like that. You don't have to move it. But I can't get the whole thing on the page unless I move these comments, remove those comments. I'm just moving those comments down to the bottom so that I can have all the code on the page. Now, do you see what I mean about this being a really bad approach? A count, B count, C count. We would actually have to change this, to look for the number of occurrences of red in that string and blue in that string. And we might not know which colors were coming down the pike or whatever. So this counting method is only good if you know in advance what specific series of values are going to be in the list. What if it's a list of random numbers between 1 and 1,000,000? You would not want to have 1,000,000 different counters. What if it could conceivably be just, 2 different values, or it could be 2,000 different values? You don't know whether, you're just going to get a string of A's and B's, or it's going to be a list, full of 1,000 different values. Like opening up the text, for a long book, War and Peace, or the entire Harry Potter books, and you're going to figure out, a count of how many times the word "the" appears in that book, as opposed to how many times Hermione appears in that book. If you don't know in advance, you wouldn't want to process it like that. Instead, you'd want to build a frequency table, a frequency count, by using a dictionary. I'm going to add a few more comments, and I'm going to pause and make sure everybody's got this going. Like that. And in this case, now that it's a list rather than a string, is letter the best term? Not really, but I'm not thinking of a better one at this point in time. Item? Value? I like value. I'm going to replace the word letter with value, but I'm going to have to replace it 4 times. There, there, and there, and there. So I'm going to type value, and then I'm going to copy that. And I'm going to paste every occurrence of that, replacing the word letter. So I had to fix it 4 times. And the only reason I did that is so that if I was looking at a list like that, this list could be a list of numbers. And then the term letter would be absurd, right? If this was a list of numbers rather than a list of words, right? 1, 1, 1, 2, 2, 4, 6, 7, 8, 88, 9, 9, 9, 9, 8, 8, 8, 7, 9, 9, 9, right? Something like that. It'd be silly to be calling these letters. They're not letters. They're numbers. Here they were letters, and then I had words, and now they're numbers, but the same code will work on all of them. So I just tried to genericize it. And so I also need to change the comment, right? Get the count for this letter. I think I'm going to change it to value. Get the count for this value. All right, and there we go. 1, 1, 1 occurred 1 time, and then 2, 3, and 4, and 5. We did have multiple 8s, and then we did have 2 999s. And if I looked at my data, that would be true. So sometimes I give you all an assignment that's supposed to open a file and read in all the text from that file so that it can do a frequency count of the letters and stuff like that. Well, you got decisions to make when you do that. Like, are you going to count uppercase letters differently than lowercase letters? And I would say no, you probably wouldn't want uppercase letters to be treated differently than lowercase letters. Are you going to count punctuation and stuff like that? No, probably not. So I'm going to comment out that one, and I'm just going to put a sentence in here, or a couple of sentences. I like to eat zebras. I also like dog food. Whatever. Now when I run it, well, there's 2 I's, there's 9 spaces, there's 3 lowercase L's, there's 2 lowercase I's, there's 2 K's. If I wanted to ignore the fact that there are uppercase and lowercase letters, what could I do to our data? I can think of multiple ways to suggest this, so I just want somebody to throw out an idea. How could we make it so that the uppercase and the lowercase letters were treated the same? I don't want to find out that there's only 2 uppercase letters, but that there, were also a certain number of lowercase. I want them all to be added up, so it'll say 4.
Dot lower? Dot
Yeah,
lower?
we could change the variable to its lowercase version. Now that would only work if we're dealing with strings. Now we're starting to break our code to the idea of it doing numbers. So this is no longer going to work, that series of numbers. But that's all right. So value, or heck, let's make the whole string lowercase before we even start. That's probably the easiest. So S equals S dot, is it 2 lower or is it just lower?
Lower.
All right. I'm going to delete that list entry completely. It's looking confusing to me having it there. All right, that's looking better. Now, what if I only wanted to count letters and nothing else? I don't want to find out spaces and question marks and periods. Yeah, I could use is alnum. So somewhere in here, we need to have some kind of statement that says if it's not a letter, ignore it. So how about if not value dot alnum colon continue, or is it is alnum? I'll find out real soon. Yep. All right. So do you see what that's doing? That's checking to see if it's an alpha character, al, or a numeric character. And if it's not, it just continues. What does continue do? It just jumps back up to the top of the list. Just like a break statement causes it to bail out of the loop and go to the bottom of the loop, continue causes it to repeat the loop instantly. So now when we run it, it should be ignoring all of our punctuation. And we didn't have any numbers in there, but it would treat numbers okay. If we didn't want to include numbers either, then we could make another change. Instead of being al num, we could just say alpha. That would let us ignore numbers completely. So dot is alpha would say, hey, I only want alphabetic values in there at all. And there we go. Not that there were any numbers, but we could put some in there just to prove the point. Right. If I go up to here and I say I like to eat 222 zebras, it's not going to show that there are any 2s in there because they were rejected by that if is alpha statement right there. Now, if you'd given me this problem in advance and said, okay, I want you to write something that'll turn this string and then do a frequency count on the words rather than the letters, then we'd probably have to call dot split to break it up. And we would want to replace all of the periods with something, make sure that, you know, our list didn't have periods in it or something like that. I'm happy enough with the way that this is. I don't know if I want to mess with it any further than that. Yeah, of course I do. I just want to see what happens if I do this. S is equal to S dot split, parentheses, quote, space, end quote, end parentheses. All right, and so it found the word I twice, it found the word like twice, it found the word to, it found the word eat, it found the word also, but it left some stuff off. It left off anything with punctuation in it, like the word zebras and dog food. If we wanted to do that, we might want to replace all the periods with empty spaces to get rid of them all. And we might want to replace all the period. Yeah. We could do that. So before we call dot split, we might want to do this. S is equal to S dot replace, quote, period, end quote, comma, and then I'm going to put 2 quotes, there's no space between them, like that. What that says is take our data and replace all the periods with nothing. It'll remove them. So when it's done with that, it'll be fine. And now it says I like to eat zebras, also dog food. And we could remove any commas and exclamation marks and whatever. That's if we wanted to treat it as a series of words rather than as a series of characters. If we're trying to treat it as a series of words, we would want to make a list of words out of it. So that's what the dot split does, is it takes a string and it changes it into a list of values, separated by, in this case, spaces. And we just did a little bit of data massage before we did that to get rid of any periods that were in it. And if there were question marks and stuff like that, we might want to have a couple more s.replace calls to do the same thing. I am going to go ahead and comment those out because I did like it being a count of the letters rather than of the words. But I'm going to make a comment here as to what this was doing. The next 2 lines let us find out the count for entire words, not letters. So we remove the periods and then call split to turn it into a list of words. All right, be a really good time for me to make sure that anybody who's trying to keep up with this has actually been able to keep up. What I was trying to show is we could do a frequency count of letters, in which case our input was a string, or we could do a frequency count of items in a list, like words or numbers. To make that list, we might need to use .split. To clean up our data, we might want to make everything lowercase or uppercase. And so on. You can use if statements inside your loop to get it to skip data that you don't like. With the continue keyword. We did that with our is alpha thing here. If the letter was an exclamation point or whatever, then we wanted to skip it. So we used a continue. Let's play with the idea of dictionaries one more time. Maybe. No, I think I'm just going to go and look at this. What if you want to remove an element? Well, just like we could delete something from a list by using the del keyword, we could also delete something from a dictionary by using the del keyword. So we had some prices. We had a price guide way up here. Scroll all the way up to the top. And then let's delete milk from our list. All I did is I scrolled way up here at the top, and so I'm going to do del price subscript quote milk end quote and subscript. So when it prints it out, it's no longer going to have milk from it. So the first time we see the list, it only had eggs and bread. Later on, it went ahead and added in milk again, and it added in carrots. But the first time, it only had those two elements. Something to think about is the order in which this comes out. These are the order in which they're added pretty much, right? Since it said I like whatever, the first letter found was an I, and then it found an L, and then it found another I. Okay, so it just increased it, and then it found a K, and it found an E, you know, and so on. So these are pretty much the order that they were inserted. What if we wanted them to be in alphabetical order instead? You can do that. I would have to Google up how to do it. What I just typed is traverse dictionary in key order in Python. Iterate through Python dictionary by keys in sorted order. Let's take a look. All right, so what I've done here is I've added a print statement. This is down here at the bottom, underneath the very bottom of my code, other than some comments. For key in sorted, we are going to sort our keys. I'm going to play with that idea just a little bit more in a minute. And then print key, comma, quote, is found, end quote, comma, L count subscript key, end subscript, comma, quote, times, period, end quote, in parentheses. Now I'm going to add some spaces to make it a little bit easier to read. I don't have to do that. All right, like that. All right, so A is found 3 times, B is found 1 time, is found 2 times. Now, saying 1 times is kind of stupid, but we see that kind of error on computers all the time, right? I'm not going to even try to fix it. So what does this lcount.keys do? It just returns a list of all the keys in a dictionary. Right? If I do print lcount.keys, parentheses in parentheses in parentheses, it's going to print all the keys that are currently in that dictionary. And it has an I, an L, a K, and an E, and a T, and an O, and an A, and a Z, and so on. So good stuff to know. How to print a dictionary. If your dictionary is named D, you do it like this. For key in D, print key, comma, D subscript key. To print in sorted order, for key in sorted, parentheses, D dot keys, in parentheses, colon, and then the same print statement. Print key, comma, D subscript key. Like that. I certainly want you to have that memorized. Please burn that in your brain right there. And you just need to know that it is possible to print them in sorted order and be able to Google how to do it if you really wanted to. So .keys returns a list of all the keys in a dictionary. You can use the IN keyword to see if something is in the dictionary to begin with. Let's make some notes. Use IN to find out if something is in the dictionary, just like you do with strings and lists. So if X in D means is X a member of our dictionary. Use .keys to get a list of all the keys in a dictionary. There's also, along with .keys, there's one called .values, which will list all the values of the dictionary. Use .values to get a list of all the values in a dictionary. Let's print that out. Down here, we printed out all the keys, and on the next line, we're going to print out a list of all the values. L.count, whoops, excuse me, L.count.values, parentheses, in parentheses, in parentheses. And there we go. Here's all of our keys, and here's all of our counts. So for our prices, let's print price.keys. Price.keys, parentheses, in parentheses, in parentheses. And then we had something called mail. We had a dictionary called mail. So let's print out mail.keys, parentheses, in parentheses, in parentheses. Just as kind of a refresher of what we had down here. Not main. Mail. Yeah. Like that. And so these are all the keys that were in our price dictionary. And these were all the keys that were in our email dictionary that had to, from, and subject. You can store anything you want as the value in a dictionary. It could be a single thing, like these numbers and these, counts and prices and things like that. It could be an entire list. Let's demo that, and then just maybe getting kind of close to the end here. But anyways, capital D, because I'm not thinking of a better name for my, is equal to that. That's our empty dictionary. I'm going to change this from D to scores. That's going to be the name of our dictionary. We're going to make scores up for people. Now scores for Sally, end quote, end quote, end brace, is equal to, and then let's make a list of scores inside square braces. She made 100, she made a 90, she made an 80. These are all supposed to be commas. I'm just mistyping them. And then a 90 and then a 95. Those were her test scores. And then scores for somebody else. Scores subscript Eric, or subscript quote Eric. End quote end subscript is equal, and Eric's going to have different test scores. 90, 100, 100, common, 90, common, 92. And so on. So this is a list. If I wanted to, I could get the sum of that. We would need a loop. It's going to be just like our other loops. It's going to be for value in dictionary. And then we're going to do something else with the value other than just print it out. So for key, not value. For key in scores, let's print the key. Let's print scores subscript key. And then let's print the sum of scores subscript key. Now the data is not going to make a lot of sense visually, right? It's not going to be tabbed and stuff like that. But what we're going to get is their name, a list of all their scores. You know what we're going to do to clean this up a little bit? I'm going to delete that line entirely for now, and I'm going to say value equals scores subscript key. And I know that values is a series of scores now. So total equals the sum of value. And the average is equal to the sum of value divided by the length of value. Now I have enough useful information to print some stuff out. I'm going to print their name, which is the key. And I'm going to print the average. And we only had 2 entries in our dictionary, right? Sally and Eric. We could add more students if we wanted to. We could be reading this stuff from a file, right? Sally and then all of Sally's test scores, and Eric and all of Eric's test scores. If we wanted to print out the scores as well as the average, we could do that. We could modify our print statement. Print value, comma, key, comma, value, comma, average, like that. Now to show all the test scores as well as their average. Like that. So you could have a list of dictionaries. You could have a dictionary of lists. That's what this is. This is a dictionary of lists. You could have a dictionary of dictionaries. You could have a list of lists. You know, these things can, can store pretty much anything that you want. They don't just have to be strings and numbers like the price of eggs, eggs and a number, or a letter and a count, frequency count of that letter. All of those other examples were either strings matched to strings or strings matched to numbers. Here we have strings matched to arrays, to lists. So dictionaries tie keys to values. Some languages call this mapping keys to values. So basically you say D is equal to whatever, that makes an empty dictionary. And then you say D subscript key is equal to the value, whatever the key is and whatever the value is. The value can be anything. Strings, numbers, lists, other dictionaries. The key can also be anything, but it's usually a string or a number. All right, here's their example of counting letters. So a frequency table could be useful for compressing a text file. What does that mean? Well, now I'm not going to even talk about compression at this point. It's getting too late in the class, period. But you could say, here's our letter counts dictionary, and then here's our string. We're going to count through Mississippi. And so for every letter in that string, the letter count subscript is equal to the letter subscript dot get plus 1. Now, honestly, I don't know how that works. Does this not blow up? I guess dot get will return a 0 if it doesn't find it. I better look up what dot get does. I never used dot get like that. And I think I saw a hand raised, and I'm sorry. I want to ignore you. Just a second. That would allow us to replace that if statement here. Up here in our code, we had an if statement. If the value was in the dictionary, we set it equal to 0, else we did something else. We could rewrite that a little bit. So for S, or for letter in S, count is equal to let's make an empty dictionary again. L count is equal to empty dictionary, end curly braces. For every letter in S, count is equal to L count dot get. And what are we looking for? We're looking for that letter, but if you don't find it, return a 0. And then L count subscript letter is equal to that count that we just found, plus 1. Count plus 1. That's a short form of what the other one was. I'm going to go up and copy the other one and put it as a comment just so that we have it to compare against. And missed a statement. Should just copied and pasted it exactly. So that's kind of neat. These two statements do everything that these 5, 6, 7 statements did. I like that better. I wanted you to see the other one because I liked showing you this in syntax to check to see if something is in the dictionary. But I may have to remember that. Should it make the code shorter? We just need to remember that 0 is the default value there because if it's not in the dictionary, we want to treat it as a 0. All right. Let's stop here. I'm going to make a Dropbox for this, and then I'll help the folks who have their hands raised. I apologize for skipping you. I have a thought. Check something about that homework assignment that I decided not to give you. Nope, but I am going to write this up as a list, as a potential project for you to do, which is to open up a text file, which is going to have paragraphs of text, and then do a frequency count of all the words. Who had their hand raised? That's funny. What were you? Sure. Yeah. Sure thing. So project idea. So, project idea, open a text file, read in all the text, do a frequency count of all the words in the data, and then print the table out. And then also print a frequency count of all the letters. Now, we've done both of these actually. If you want to make it really cool, I could ask you to make a bar graph out of this. We did a bar graph last time, but I'm not going to ask you to do that. That's probably the simplest of all the projects at that point if I didn't add anything else to it, like making a graph out of it. I'm going to leave that alone. I mean, just leave that as the go-to project if you're looking for something easy based on examples we've already done.